Okay, so the topic for this video is going to be parallel and perpendicular lines. Specifically, what we're going to be going over here is how to write the equations of these lines. How do we write the equation of a parallel line? How do we write the equation of a perpendicular line? All that good stuff. So to recap a little bit, parallel lines are coplanar lines that never intersect. All right, we know what they look like. It looks something like this. And we mark them by putting the little tick marks on them. Right, and it might be worth jotting down over here if you got some room. The symbol for parallel lines is those two vertical lines. Important thing to remember here in our dotted box here is that parallel lines always have equal slopes, right? They're going to have the exact same slope if they're going to be parallel. So example 1 here says circle the two lines that are parallel. We have those 4 equations down below. We got to pick the 2 that are parallel. Notice right here, y equals negative 3x plus 5. And then option C has y equals negative 3x minus 7. So those are going to be the 2 lines that have the same slope. They're both written in slope-intercept form, where that coefficient on the x is your slope. The other one's the 4 and the negative 4. They're close, but they're opposites, so no good there. So parallel lines have equal slopes. For perpendicular lines are lines that intersect at right angles. And of course, they are going to look like this, where they are going to intersect right at that right angle there. The symbol for perpendicular is kind of an upside down T. And then we've got perpendicular lines have opposite reciprocal slopes. Now, what does opposite reciprocal mean? That means that you take it and you flip it, and then you change the sign on it. Opposite means change the sign, reciprocal means flip it. So which ones have been flipped and had the sign changed? Well, let's see here. I notice right here that we've got a slope of 5 and a slope of negative 1/5. And those are going to be opposite reciprocals. And then I also note that we've got a negative 5 and a positive 1/5. So we've kind of got 2 sets of perpendicular lines. So maybe you could circle A and circle C because those are perpendicular. And then maybe box B and box D because those are perpendicular. Because the opposite reciprocals, right? 5, you could also kind of imagine it as 5 over 1. 5 over 1 being flipped upside down would be 1 over 5. And then we change the sign to negative 1 over 5. So that's why A and C. And then we can imagine negative 5 over 1 being flipped to negative 1 over 5. Change the sign to 1 over 5. So that's why B and D would be. All right, so we know how the slopes work here for parallel and perpendicular. Now let's talk about writing some equations. To write an equation in slope-intercept form, you need to be given a slope and a y-intercept. And that is in the form y equals mx plus b, where m is the slope and b is the y-intercept. So example 3 here just wants us to write the equation of a line given the following information. And let's just plug that stuff in. So if I want to do y equals mx plus b here, it'd be y equals 3x minus 5, a slope of 3, a y-intercept of negative 5. For b, we could do y equals negative 1x minus 10. And for that one, if we've got a slope of negative 1, really we don't even write the 1 part. We would just say y equals negative x minus 10, because that 1 is implied. For 3, we could say y equals negative 2 over 3x plus 6. And for 4, we could do y equals 4 over 5x plus 3. So once you've got your m and your b, you're good to just plug it on in to write that equation. So that's how we write a basic equation. But now let's get back to the parallel and perpendicular stuff. So if our initial slope is 2 over 5, a parallel slope would also be 2 over 5. And the perpendicular slope, remember, we flip it and we change the sign, so that'd be negative 5 over 2. For number 2, parallel slope would still be negative 1 over 7. Perpendicular slope would be positive 7, because as we flip it to 7 over 1, the 1 on the bottom we don't need to write, and we change the sign back to positive. Parallel slope for negative 6 would be negative 6. Perpendicular slope would be positive 1 over 6. Parallel slope to 5 would be 5. Perpendicular would be negative 1 over 5. Parallel slope to 3 over 8 would be 3 over 8. Perpendicular would be negative 8 over 3. All right. So recap on slope formula. The slope formula is used to find the slope between 2 points, and the slope formula looks like this: y2 minus y1 over x2 minus x1. Change in y over change in x. So let's give that a shot here, because example 5 wants us to determine if the lines formed by AB and CD are parallel, perpendicular, or neither. So let's check out AB first. So I'm going to do the slope formula for AB, so m of AB. Now, if I'm doing AB, this is my x1, y1. This is my x2, y2. So y2 minus y1 would be 7 minus 2 over x2 minus x1 would be 5 minus 1. 7 minus 2 is 5. 5 minus 1 is 4. So I could say the slope of AB is 5 over 4. Now let's do it for CD. So m of CD. This will be my x1, y1. This will be my x2, y2. So y2 minus y1 would be negative 1 minus 3. x2 minus x1 would be 3 minus negative 2. Remember, minus a negative would be plus. So negative 1 minus 3 would be negative 4. 3 plus 2 would be 5. So m of CD would be negative 4 over 5. So if I have a slope of 5 over 4 and a slope of negative 4 over 5, hopefully you recognize those are perpendicular slopes. So these lines are perpendicular. Okay, so we know how slopes work. Now let's get into the writing of the equations. This says use the given information to write the equation of a line that is parallel or perpendicular to the given line. Okay, so example 6 says write an equation parallel to y equals negative 5 over 4x plus 6 and goes through the point negative 4, 2. Okay, so the original slope there is negative 5 over 4. And if we're going to be parallel, we need to also use a slope of negative 5 over 4 because parallel lines have the same slope. So we know that our equation needs to be written in slope-intercept form, y equals mx plus b. Here's what we're going to do. We're going to use that parallel slope as our m. We're going to use negative 4 as our x. We're going to use 2 as our y. We're going to plug this stuff in and figure out what our b value needs to be. So this should be 2 equals negative 5 over 4 times negative 4 plus b. Okay, now let's multiply the slope times the x value. So negative 5 over 4 times negative 4 is just 5. Let's subtract that 5 then from both sides. 2 minus 5 is negative 3 is equal to b. So my final equation here will be y equals negative 5 over 4x minus 3. So you figure out your slope, plug that in along with your x and your y to figure out your b. And then, once you've got your m and your b, you just write your equation. Let's try it with perpendicular this time. So this says write an equation perpendicular to y equals 1/5 x minus 4 and passes through 1, 4. Now the given slope on this one is 1/5. But if we want to be perpendicular, we don't want to use the same slope, that'd be parallel. So we want to use negative 5. That's the opposite reciprocal. So let's set up our y equals mx plus b and figure out what we're plugging in. I'm going to plug in negative 5 for my m, 1 for my x, and 4 for my y. So if I do that, that's going to be 4 equals negative 5 times 1 plus b. That'll be 4 equals negative 5 times 1 is negative 5 plus b. If I add 5 to the other side, I get 9 is equal to b. So this would be y equals negative 5x plus 9. All right, this one says write an equation that is perpendicular to 2x minus 3y equals 5 and passes through 4, 1. Now this one's a little tricky because we don't know what the given slope is right now, because this equation right here is not in slope-intercept form, so you can't tell what the slope is. It's in standard form. So let's do a little bit of work here to get that slope by itself first. So 2x minus 3y equals 5. Let's convert this into slope-intercept form. So let's subtract 2x to the other side. That would give me negative 3y is equal to negative 2x and a positive 5. And let's divide everything by negative 3. If I divide everything by negative 3, what I'm going to end up with here is y equals negative 2 divided by negative 3 is positive 2 over 3. Those negatives cancel out. And 5 divided by negative 3 is just negative 5 over 3. So this is my given slope, 2 over 3. Now we had to do a little bit of work there, but now we're in the clear, because if the given slope is 2 over 3, then the perpendicular slope is negative 3 over 2. So now we are good. Y equals mx plus b time. Let's use negative 3 over 2 as our m. Let's use 4 as our x and 1 as our y. So 1 equals negative 3 over 2 times 4 plus b. Negative 3 over 2 times 4 is negative 6 plus b. If I add the 6 to the other side, I get 7 is equal to b. So my final equation here, y equals negative 3 over 2x, that perpendicular slope, plus 7. Okay. What do we have here? Write an equation that is parallel to 4y equals 2x minus 2. That would be the point negative 6, 3. Okay, same deal. That equation there is not in slope-intercept form, so let's get it in slope-intercept form first. 4y is equal to 2x minus 2. This one's a little bit easier. All I got to do is divide everything by 4. 2 over 4 is 1/2. Negative 2 over 4 is negative 1/2. So the slope here is 1/2, so that's going to be my given slope. And if I want to be parallel lines have the same slope, so I'm just going to use 1/2. So let's set up our y equals mx plus b. My parallel slope is 1/2. My x is negative 6. My y is 3. Plugging everything in, I get 3 is equal to 1/2 times negative 6 plus b. That'll be 3 is equal to 1/2 times negative 6 is negative 3 plus b. And then adding the 3 to the other side is going to give me 6 is equal to b. So this will be y equals 1/2 x plus 6. All right. I believe it is your turn to shine here. You've got one parallel, one perpendicular, and then you've got one where you need to do the slope formula to determine whether those lines are parallel, perpendicular, or neither. Give those a shot and then come back when you're ready to check. All right, on this first one, your given slope was -6, so your parallel slope should have been -6. So this will be y equals mx plus b. Plugging things in should have been 4 is equal to -6 times -2 plus b. That's 4 is equal to 12 plus b. Subtracting the 12 gives you -8. So this should have been y equals -6x minus 8. For example 2, we want to be perpendicular to -2 over 3x plus 4. The given slope is -2 over 3, so perpendicular would be positive 3 over 2. So y equals mx plus b. That should be 7 is equal to 3 over 2 times 6 plus b. That's 7 is equal to 9 plus b. Subtracting the 9 gives me -2 for my b, so this should be y equals 3 over 2x minus 2. Then our last one, we want to check out the slopes of AB and CD. For the slope of AB, we should have done 8 minus 6 over 0 minus -3, which would be 0 plus 3. 8 minus 6 is 2. 0 plus 3 is 3. For CD, we're going to do 6 minus 4 over -5 minus -8, which would be plus 8. 6 minus 4 is 2. -5 plus 8 is 3. So I got a slope of 2 over 3 and a slope of 2 over 3. Those lines are parallel. All right, hopefully that went well, and that's going to wrap it up for this video.